All right, so the next thing we're going to talk about in terms of graphs is symmetry, types of symmetry that you have. So the first type of symmetry that we're going to be looking at is y-axis symmetry. So you definitely want to write down how you can figure out if it has y-axis symmetry or not. So you want to write these down so you can refer back. So y-axis symmetry is where if you fold your graph over the y-axis, it would match up onto itself. So if we look at this original part, the xy, if we were to flip it over the y-axis or put a mirror on the y-axis, you would see this on the other side. If you folded it on the y-axis, it would match up with that over there. So what that means is that for every point xy on the original graph, the point negative x positive y is on the graph also. So you're just changing the sign of the x, but the y stays the same. And to test if you have y-axis symmetry, you put negative x in for x in the equation, you simplify, and if you get the original equation, it has y-axis symmetry. Way to remember this is you're going to have to plug in negative, the opposite letter of what you're trying to find. Kind of like intercepts, x and y intercepts, or plug in 0 for the opposite. To find the symmetry, you're plugging the negative value of the symmetry you're trying to find. Here I'm trying to find y-axis symmetry, so I'm plugging in negative x. Another type of symmetry is x-axis symmetry. So that would be if you folded it on the x-axis, it would match up on itself. So in this case, the x value stays the same, but the y value is the opposite sign. So for every point xy on the graph, the point x negative y is also on the graph. These are usually not functions. If you have something with the x-axis symmetry, it usually does not a function. If you look at this graph that we have as an example, it fails the vertical line test. And so our test for x-axis symmetry, like I said, you plug in negative, the opposite letter of what you're trying to find. So we're trying to find x-axis symmetry, opposite the x is y. So we're plugging negative y in for y. We are simplifying. And if you get the original equation, it has the x-axis symmetry. Our last type of symmetry is origin symmetry. And that means for every point xy, it's the negative for both. So negative x and negative y is also on the graph. So here's a point xy here. So you did opposite negative x and negative y is on the graph. So for origin symmetry, we have to substitute negative x in for x and negative y in for y also. So you plug in both negatives in for both letters. You're simplifying, and if you get the original equation, then it has that origin symmetry.